Okay, so hello everybody and welcome to our webinar on dyscalculia, dyslexia and maths learning difficulties with Professor Steve Chinn. I can't even tell you how excited I am to have this webinar tonight. I met Steve a little while ago and I'm very, very pleased that he's agreed to come on board and do this webinar for you all. I know that maths difficulties it's not fun for anybody, and with the new curriculum it's harder and harder for children to grasp and to make progress. So Steve I've admired for quite a long time, and I think he's been around for a long time too, and he's very well known as one of the leading experts in his field. So I will pass you over to Steve to introduce himself and to get along with the session. I will ask you, if you don't mind, I do have the chat box here, but we're going to save the questions until the end, and rather than post them into the chat box, can you please, if you have a look, you can see that there is actually a Q&A box on the screen. If you just put your questions in there, and we will answer them at the end, but please bear in mind that we only have a short time for questions, so we'll answer what we can. Steve, are you ready?
I'm ready. Oh, let's see if we get the technology going.
Good luck.
Okay, so share screen. Can people see the screen? Can people see me? Screen's more important.
Yes, Steve, I can see you and hear you.
Okay, then we'll get going. I'm absolutely delighted to be doing this webinar for Sarah on Operation Diversity. She's got a lot of passion about what she does and helps a lot of people, so it's a great pleasure to help her. I'm going to talk about maths learning difficulties and dyscalculia. Now, way back in 1981, when I started to work with dyslexics, and I'm a science and maths teacher by origins, I was really surprised to find that these dyslexics couldn't do maths in the way that I wanted them to. And over those years since then, the word dyscalculia has come into more and more common usage. But I chair the committee for the British Dyslexia Association. I chair the Dyscalculia, call it both those things. So I can only cover some of the ground in and out, obviously. Way back again, we did do full postgraduate training at master's level. So it's a good overview, I hope. I hope you find it interesting and useful. Well, dyscalculia is a definition in the UK. Currently, there's pretty much nothing on the government website in the UK. This dates back to 2001, and it's a good friend and a person I admire greatly, Professor Brian Butterworth, did that. Probably would change it now, but the government aren't quite ready to take a new definition yet. So it's a condition that affects the ability to acquire mathematical skills. We might talk about that being arithmetical, but Brian makes that clear by saying dyscalculic learners may have a difficulty understanding simple number concept. This starts at the beginning of maths. Lack an intuitive grasp of numbers and have problems learning number facts and procedures. That's such a big issue. So many kids can't learn those facts, can't commit them to memory. Highly demotivating. And when some of these children do maths, and even if they get a right answer or use the right method, tend to do it mechanically and they don't really understand what they're doing. So one of the early things about number sense is a thing called sabotaging. So let me just check out your sabotaging skills. So are you ready? How many dots did you see on the screen? Well, there were 4. You ready? Next lot. That probably went beyond your sabotaging ability. So there were 9. Now you might be able to picture that 9 and count them. Some people can sabotage at 9, but most people will sabotage in quite low quantities. But that sets your early understanding of quantity. How many there? You ready? 10. You probably knew that was 10 because I use patterns. And patterns are very helpful to give us a secure visual image of the quantity associated with the digits that tell you the maths representation of that quantity. So what you see on the screen, sabotaging small amounts, bigger amounts, you either won't know or you maybe count from a retained image in your head. But if I can use patterns, I can give people a consistent quantity associated with the number that they see. I like to chunk numbers, so the 10 there is 2 5s, and I like to develop patterns, part of the deal. A more recent definition came from the States in 2013, and they talk about dyscalculia being about production and comprehension of quantities, numerical symbols. So what I've just been saying, basic arithmetic operations. These are the kids that aren't going to get very far in maths. And in America, they tend to say things that we don't hear, and that is, it's not consistent with chronological age. Well, we'd say that. Educational opportunities, we probably say that. Intellectual abilities might be more challenging for us to accept. I think some of the issues around intellectual abilities are quite interesting. Again, in an hour, I can't do everything. If you're a low achiever, people may not notice you have maths difficulties in particular. It's a specific learning difficulty. And if you're very bright, you may not be underperforming to the level where you will get support. It's best to be average, really. So intellectual abilities are interesting as a factor. What the Americans say is, here are some key characteristics. Difficulties in remembering number facts, so like our definition. Inaccurate and slow. Slow is a key issue because we expect kids to do maths quickly. Ineffective or inaccurate mathematical reasoning because they haven't really understood the early work, and that, again, very important. And avoidance is a very big issue. Starts when kids are very young, but it carries on. People will avoid what they can't do. Common characteristics, well, this is off my Maths Explained website. So just to summarize a few interesting ones. A lot of these children can't count backwards. They may have just grasped somehow how to count up to 20, but counting backwards is much harder. A poor sense of number. They just don't know what numbers are. They can't estimate. They don't see 9 as very close to 10. 98 is very close to 100. Such a big issue, difficulty in remembering basic facts. The UK government is going to test children on their multiplication facts. It's going to be a disaster, I suspect, for many children. Place value is critical to understanding our number system. And if you don't understand it, then you really will struggle advancing through arithmetic. They're slow. The culture of maths is that you have to do things quickly. There's a lot of stuff about speed in maths. And I found over the years and in all my research that addition is often the default operation. After addition, subtraction, not as good. Multiplication, not as good. Division, don't go there. And they tend to have very weak mental arithmetic skills. I'll explain why. But again, there is this assumption that children can do mental arithmetic and that it's good for them. Well, a lot of children can't, and that makes it not good for them. And you get very high levels of mathematics anxiety to the point where it may actually stop the child from doing further maths. Well, we're in the early days of dyscalculia, and Daniel Ansari from Canada is just an incredibly amazing developmental cognitive neuroscientist. And what he's saying, DD, that's developmental dyscalculia, as opposed to acquired dyscalculia, which you might have got from a brain injury or brain damage. Anyway, there's no clear conclusion as to what causes it, and we don't have a universally agreed set of criteria for diagnosing. That is not an excuse for not diagnosing, and it's one of the reasons I use maths learning difficulties, because believe me, they are so common across children in the UK and probably beyond as well. So, and there will always be a spectrum, as there is with dyslexia, from very severe to moderate to mild. So, maths learning difficulties and dyscalculia. A good question is how many? How many kids are we expecting to see with difficulties of this nature? That's my symbol to say there'll be a spectrum. So, here's a bit of data from the UK, some data I collected for a standardized test I set up. That's a fairly basic subtraction. It's a little bit sneaky. I'll explain why later. At 10 years old, only 54% of my sample could get that right. At 13, it was less than 3/4. And even at 15, the year they're entering for GCSE, almost 20% can't get that right. More tricky, 13-year-olds, not a third, less than a third of UK kids can do that. We have big problems with maths. Less than half of 15-year-olds can do that. So I think we've got a big problem. Some of the research suggests at least 20% of our young adults are functionally innumerate. So it's a big problem and we need to address it. And the way we teach children with dyslexia and dyscalculia will help a lot of other children who are struggling and a lot of children who are not struggling. So the research, as Ansari suggested, is not clear on this, but papers from around the world suggest round about 5% of kids have really severe maths difficulties to the point where you could call them dyscalculic. I think in terms of difficulties in maths, where it's going to make you not very functional, it's around 20–25%. Okay, let's look at what's involved. What are the things that might contribute to being dyscalculic? Some of these will be the same as the difficulties associated with dyslexia, which is why my early books were called Maths Difficulties and Dyslexia, because in those days that's where I was focusing. Now I talk about maths difficulties and dyscalculia. These are some of the issues. An ability to work with symbols. That is so very critical in maths. So many people say that. Maths vocabulary, and again, this is both these things affect dyslexics. The vocabulary in maths, in early maths, can be very confusing. I'll give you some examples. And we use words from everyday life in a very mathematical way. Short-term memory, your ability to remember information for a short time. Short-term memory does not store. If you give a kid a set of instructions and they can't remember them all, there's no way they can get them back, however much effort they put. WM is working memory. Again, it doesn't store. It's the memory you use to work out stuff in your head, particularly maths. And if you've got a working memory for 3 things and the process you're trying to do has 4 steps, you can't do it. Speed of processing I've mentioned. I said long-term maths memory because I think memories are also specific, like intelligence, and that's another issue to look at. But it may be you could be a good speller and poor at remembering maths facts, or vice versa. So a long-term memory problem for maths facts and maths procedures. I won't have time to cover tonight. Being flexible in the simple procedural processes, because they're not simple if you forget them. Being able to see sequences is important in maths. Counting forwards and counting backwards, I've mentioned. And I've mentioned anxiety, and I will do so again. If you can generalize with information, if you can see patterns, that will support your memory. And we need to do a lot of input to help children
Steve, your microphone's just frozen out a second ago. Do you think you could just go over that last bit again, please?
find the patterns. Not loud enough?
Yeah, that's better. You're back now. We lost you for a second.
Only a second.
Yeah.
So am I okay? Not too loud?
No, we can hear you. Do you want to just go over that last bit again, though, please?
Okay.
Lovely. Thank you.
These are some of the key issues that can create difficulty in mathematics, and you'll recognize some of them for language as well. Illustration here of the inflexibility of some schools or the lack of knowledge. So the parents were concerned about this young child not being able to do maths, and that maths is stressful and the kid's getting distressed at home. So the psychologists suggested to the school that they let him make little jottings so he's not reliant entirely on his memory, and the school might give him some extra time. But the school said, nah, he must try his best. That's just such a terrible thing to say to anybody. Try your best. Okay, you got to get the classroom ethos right. That last example obviously was not going to get the classroom ethos right. Your communication's got to be so effective with these kids, and that will make it more effective for all the children. So, very famous saying from America, a wonderful expert over there, Margaret Rawson. Teach the subject as it is to the learners as they are. All the methods I use for maths are mathematically sound. There's no tricks, there's no jokes, it's all mathematically sound. And that is very different to some teachers saying, why can't they learn the way I teach? Or government specifying methods for kids to learn. So one of the big issues in the classroom is this recall or retrieval of basic facts and procedures. So we need to teach children how to use what they do know to work out what they don't know, and that's important. So I, as a parent, might want to ask, what are you doing to differentiate for my child in maths? So it might be the amount of work you demand from the student. It might be the way you present information. You may have noticed my screens, no clutter. You'll also may have noticed that I'm using colored fonts, and you also may notice that I'm often using different colors so you can highlight what you see. So let's give some more specific examples. Avoid clutter. Give the kids who can't organize their work squared paper. A lot of the stuff you do is about preventing the problems, not waiting until they become a big issue. And every little thing you do to help makes life better. You might give out times table squares so that that doesn't become an issue. Just one very important thing. Don't let kids learn something the first time incorrectly, because the way you learn something first time is a very dominant entry to your brain. So check that they've learned the right thing, guide them. I like to use materials and apparatus. I'm a maths teacher way, way back. Critical for me, or visual images, or or both. Pace and speed your lesson. Watch the kids. Make sure they're not falling behind. Start your lessons with reviews and revisits. Very important. Memories are fallible. Memories are designed to forget. Mine's brilliant at forgetting. So keep reminding people. And there's some great questions to ask in maths. One of them is, how did you do that? Tell me what you're doing there, in a very gentle way, because it's so interesting to hear how some kids do. Intervention. How far back do you go when you're doing intervention? The answer is a long, long way. Often back to the very, very basics, because early knowledge is critical to the way a child progresses. Dave Geary is one of my heroes, American researcher, and this is from a paper of his. And what he's saying is, kids who start school without a solid understanding of number words, quantities, they are at heightened risk throughout their school time for poor mathematics achievement, and thus poor employment relevant quantitative skills. You need to start kids very young so that they catch up for anything they might have missed when they were young. And this is major research, again from the States. 3 key findings from a massive piece of research. Kids come with preconceptions about the world. If you don't deal with that and engage that, they may not abandon that to grasp new concepts and stuff they're taught, or they may learn them for the purpose of a test. And what's really, really critical is the finding says revert to those preconceptions afterwards and outside the classroom. So here's an example. Sometimes when people introduce subtraction, they say, take the little number from the big number in the very early stages. So here's a question I showed you earlier. And a lot of people get 23 for this because they take the 3 from the 6, like I've just highlighted, and that is not appropriate. But if you learn that as a first learning experience, it's going to be there in the brain. So what are the sort of early activities you can do, and where are they going to go? Maths develops, which is why you have to go back. If you haven't got the foundations, it can't develop. So what are the sort of things that might suggest a kid's going to have difficulties in maths? So this is research from Belgium. You have to be able to do 2 things, seriation and classification. I'll tell you what they are right now. You have to have early logical thinking skills. And you have to know how to count, and you have to know how to count conceptually, not just like a parrot, and procedural knowledge as well. So seriation, I'm back to my random dots, is about knowing how to put those clusters, separate clusters, into order of quantity. And you can talk about, is it bigger or smaller when you're comparing 2 groups? And that's another great question to use in maths. Low stress question. Is it bigger or smaller? And it just helps. So seriation is about putting things in order of quantity, size, or value. Classification is being able to see the similarities in a cluster of objects and ignore the differences. So those are all foods. They're all things we can eat. And I kind of think we use pizzas a great deal in maths. I'm always amazed kids still eat pizzas. They're used so often in maths. Now in algebra, we classify, we group things together. So that very, very early skill you do in algebra. So I can group all these things here according to what they are. And that's using those very early skills. And I can do it in quite advanced algebra. The roots of maths go a long way back. I'm not trying to put you off by showing you algebra. I want to show you that the roots go a long way back. So, counting forwards. I like to combine symbol, 1, with visual image, 1. 2, image and symbol, very important. 3. Now, when you're doing this with kids or adults, you can use it appropriately. So what you can see on the screen there are 3 dots, and you might see them as 2 dots and 1 dot. You might see them as 1 plus 1 plus 1. You might see them as 1 plus 2. You can talk about quantity and relationships in numbers very early on. So you might talk as 4 as being a square. There's always that opportunity to use simple stuff and take it to higher levels. 5, 6. You'll notice for 6, I use 5 and 1 because I'm kind of heading for 10 as being 2 5s. And likewise 7. More common to see that as 5 and 2. This breaking down numbers and quantities into key values is a very important part of my Maths Explained video tutorials. And 9. Now, I'm stopping at 9 because those are single-digit numbers. And that sounds crazy. But when we do 10 and we write 1 and 0, that is really sophisticated maths. Now, I'm not saying avoid 10, but I'm just saying don't underestimate 10. It's tricky maths. That series was all about adding 1. If I count backwards, that's about taking away 1. Now, one of the characteristics you don't see as often about dyscalculics is they are often not good at reversing a process. They can do it forwards, but counting backwards is much more difficult. Reversing procedures that they do in maths as well, tricky. So here I am taking away 1 at a time. So I'm taking away, I'm counting backwards. Your vocabulary again can be very flexible and help kids understand, and end up with nothing on the screen, 0. 0, by the way, causes a lot of issues for kids. So that was subtracting 1. Sometimes people say, what's good about maths? This is consistent. Spelling isn't, but maths is so predictable. Well, I mentioned 10. Well, as soon as you get to 10, you're using 2 digits. And that's our place value system, which is base 10. 12, 2 digits. And then all these teen numbers in blue are a problem linguistically. Because we say 13, and 13 is 1, 10, 3 ones, and that's not the way 13 is structured. So 15, for example, we say 15, but in digits we write 1, 5. So it's kind of confusing. So you might need to model these teen numbers when you first introduce them or when you're going back. So things to think about all the time. If it's an early learning experience that's wrong instead of right, it's a problem. 20 is not too bad because at least that's 2 10s, 0 1s. 20 sounds, well, you can convince someone that could be 2 10s. So the teen numbers really are a problem because of this reversal. 15, 5 and 10, just a problem. 10s, that's why a lot of kids write 51. You tend to think that's a dyslexic reversal, but it may be down to the illogical number words we have in the teen numbers. And it's a shame that those are the first 2-digit numbers that kids meet. Later on, 42 is not quite so bad. At least you can believe 42 could be written as 4 and 2. So sometimes learning is actually about unlearning and inhibiting wrong experiences from early learning. Now, I mentioned using what you know to work out what you don't know. Well, when I started in this field way back, like I said, in 1981, and I didn't say introduction, I have been principal of 3 schools for very dyslexic kids, one of them in the States, 2 of them in the UK, one of those I founded myself, and it was awarded beacon school status by the government so we could train people. So I've been around dyslexic kids, teaching them for a long, long time. And I used to say to my kids, how are you getting on with your times tables? Which are the ones you really know? And the ones they really know are 1, 2, 5, and 10. And then I can use those to do 20 and 50 and 100. Use the facts kids know to work out the facts they don't know. So these are my core numbers. And again, I'm giving visual images to relate the quantity to the symbol, the digit that we use. So like I said just a few minutes ago, 10 is 5 and 5. I can use my visual image, like I said, to tell me things. That can show me that 10 is 5 add 5. It can show me that 5 is half of 10. Visual images are much stronger. So here's a very core fact. 5 add 5 is 10. It's all to do with our fingers. We've got 5 on one hand, 5 on the other. Add them together, and I've actually used my visual to show the putting together. That's 10. There are some visual images I want to have them fixed in kids' heads. So now you can see why I do 6 as 5 and 1, because when I put two 6s together, you can see I have 10 and 2. And that's a place value thing. A 10, 1 10 plus 2 1s put together, and that's 12. Always a chance to review and revise and to keep refreshing those concepts. And of course, you would expect 7 plus 7 to result in 10 and 4, so 14. Using what you know to work out what you don't know, and using what you know to understand mathematical procedures. And that's very important, because if you're trying to catch up, you've got to be super efficient in the way you teach. You can't go slower. You've got to go better. 7 times 6, multiplication facts. I ask teachers when I'm lecturing, and I've been doing it for decades now, what percentage of 10-year-olds don't know the times table facts? And I guess the most frequent answer I get is 70%, which is why I think the new government tests are going to be very interesting, unless you're a child. So a lot of people don't know 7 times 6 is probably one of the toughest facts on the times table collection. So let me show you what you can do, not completely, but the structure of how you do this. Well, a lot of people learn times table facts, just learn them. They don't know what they mean. But 7 times 6, and here's vocabulary, 7 times 6 is abstract. You can make it less abstract by saying 7 lots of 6. 7 6s added together. Well, that's not an efficient way of working out what 7 6s are. But if you do know your 5 times table and your 2 times table, and you really have those on automatic recall, then 7 lots of 6 is 5 lots of 6 and 2 lots of 6, which is 30 and 12, which is pretty easy to add together. So it's 42. Now, that's not immediate, but it does teach you how to work out facts. And it does teach you a lot about the process of multiplication, which you can build on later on. It's about what else are you teaching. And it applies to 7 8s, because that's 5 8s and 2 8s. So that's 40 and 16, 56. So a lot of the stuff I like to use when I'm teaching is teaching more than just the one objective. I'm building in a lot of other stuff. Well, we talked about symbols, or I did, and just how important understanding symbols are in maths. Well, it's actually more complicated probably even than spelling, because there are symbols you see, some symbols you don't see, and sometimes there's a symbol for something that's not there. So symbols in maths, you can just forget sometimes how difficult they are. So 42, I've mentioned 42 before, but we kind of know that the 2 means 2 ones, and the 4 means 4 tens, 40. So the 4 actually means 4 times 10. We have to know that. So we have to know that's 42. 103, we have to know that the 1 is 100, the 0 is 0 tens, and the 3 is 3 ones. Without the 0 there, those 2 digits that were left would be 13. So we have a symbol for something that's not there. There aren't any tens, but we have to tell you there aren't any tens. Otherwise, you don't know it's 103. And we forget just how tricky this stuff is. Fractions hide the division sign, and that really causes problems because kids are suddenly faced with a sequence that isn't what they're used to. So if I divide 1 into 2 equal parts, I get a half, and I write it like that. A third means 1 divided by 3. Doesn't say so unless you know. So here's my 1. There's the 3 equal parts. I've got a third. Third, as you know, is smaller than a half. But my sequence, 1 over 2, 1 over 3, is getting smaller. My sequence 2, 3 would be getting bigger. So, algebra, missing symbols in algebra. 5n in algebra means 5 multiplied by n. Don't use multiplication signs in algebra. We don't use division signs like we don't in fractions. A over b in algebra means a divided by b. So kids have to learn symbols, but they also have to learn the symbols that aren't there. And then we get to digits and the font size and the location. That little 2 up there means n times n. That's what it tells me. If I make it big again and put it that side of the n, that means n plus n. So we have to be so careful when we're explaining symbols. We have to give kids reasons as to why the symbols are there doing what they're doing. And I just thought I'd put that up because it's a billion. So by using that little 9, I can simplify that billion, but only simplify it if you know what it means. Yeah, I don't know why I'm doing this. I think it's just because I like it. I like base 10 blocks in maths, and the little 1 centimeter, 1 centimeter, 1 centimeter cube is 1. It's the root of everything. And that's 1. 1,000 is 10 centimeters by 10 centimeters by 10 centimeters. So still pretty small. So I just thought I'd quickly show you. There's a person. There's the little 10 centimeter cube. There's a meter cube. That would contain 1,000,000 of those little centimeter cubes. And then, because a kid once asked me, what's a billion? A billion would be a building that's 10 meters high, 10 meters deep, 10 meters wide. So that's what a billion looks like. It's kind of handy if you're ambitious financially. I like to have things like that for discussions amongst the kids so they can talk about things in a non-threatening way. Well, you can get books about maths anxiety. I always say you don't get books about history anxiety, geography anxiety, or art anxiety, but you do get them about maths anxiety. And this whole area of anxiety and attitude and motivation is called the affective domain. We spent a lot of time looking at that in my own school. And in fact, the professor from Exeter wrote a book about how we dealt with a lot of these issues. And in his research, we were successful. What I want to avoid is withdrawal. I don't want kids dropping out of maths, particularly as young as 7. Now, they've got 9 more years of compulsory maths, or longer these days, because the government thinks that'll help. So withdrawal we want to avoid. This is the sort of stuff that make kids withdraw. So this is from the Times Educational Supplement a little while ago, not that long. And they picked out 10 motivational maths resources. So number 6 was timed tables. You probably guess what's coming here. The game challenges students to find the answers to times table questions, but to make it extra exciting, they must do so against the clock. That's meant to motivate? Well, don't work with the same kids I work with. I love this little diagram. Maths anxiety builds. Learn these basic facts, son. Quickly. What's 627 minus 226? Quickly. Let's do some fractions. Fractions, by the way, are hated around the world. Not by everybody, thank goodness. Let's do some algebra. Anxiety builds, and that's very sad. It's real. There is, because of the amazing things we can do when we look at brains now, there is actually a neurological evidence that when you say to some kids or adults, indeed, you're going to have to do some maths, the prospect of doing that, the same bit of the brain lights up as the bit that lights up when they're anticipating someone about to hurt them physically. And I think a lot of that is the fear of negative evaluation. Maths is very harsh. It's right, it's wrong. So this Lundberg was a guy I knew quite well. A Swedish guy, died, unfortunately, some little while ago, not long. Very, very wise man. And he said, over all these cognitive stuff, all this thinking stuff, you've got all these emotional things. Helplessness, depression, need of achievement, anxiety, self-esteem, self-concept. It's a big deal. And in my schools, as we got better at teaching the maths, because there was no stuff around in the 80s to tell us what to do, what we learned was it just highlighted how much we had to do about anxiety. So a couple of definitions, hard to define it accurately and comprehensively, but one definition is if something you're going to do is going to make demands you're not ready for, so hence the brain activity. And people can't dismiss it. It's no good saying stop being anxious. They can get obsessed. And sometimes the anxiety is actually related specifically to the maths, and it is rarely facilitative. It's nearly always debilitative. Bit of anxiety is not bad for you, but when it becomes debilitative, that's not good. And the things that make you anxious is if you know you can't do maths, if the instruction's wrong, and it might just be that it's too quick, or that the stuff on the board's illegible, or there's too much clutter around. Work tasks that are not well designed, not well structured, not well progressed in difficulty. A curriculum that doesn't take into account that not all learners are geniuses, not all of them are average. The extreme judgmental nature, this right and wrong, the way you give out the marks can make stress and anxiety. And anything that's inconsistent will make you anxious, unpredictable, and change and uncertainty, not good. Well, there are some beliefs and culture that don't help the way maths is perceived. And they're often believed on, it worked for me, so it'll work for everybody else. I think, and in fact, I've got an article in SEN magazine, the June edition, about beliefs and culture actually discriminating against kids with special needs, like expecting to do things quickly or things that are beyond their working memory capacity. I think it actually is discriminatory, and that's not good. But they're hard to change because people think their beliefs are right. That's why they're beliefs. And what they do when they get new observations, they just kind of make them work for them. And Kahneman, who's, again, another one of my heroes, Nobel Prize winner, but not a mathematician, actually an economist, but he uses maths to explain some of his ideas. It doesn't matter how much evidence you throw at some people, those beliefs aren't going to change. And one of the beliefs that's so damaging in maths education is all children should learn the times table facts. I'm not saying they shouldn't be able to access them. I want to show them ways to work them out, because that's long lasting, not just rote learning. Okay, finally, oh, you say at last, reviews and going back. Go back to the foundations. Much better to start a lesson with a review or a revisit, and you can tune that to the age and the kids you're working with, and that's very important. Get those early learning experiences really rooted and show how they pop up in the maths that's coming up now. Maths is so developmental, and you can't develop if you haven't got the foundation. And sometimes when you're at a higher level, it actually makes you reflect back on the earlier stuff and maybe even understand it better. And critical is to listen to your learners, which means you've got to give them a chance to speak and be listened to. Well, there's a set of video tutorials that I've just updated that kind of show you more about how I teach. And if you buy them through Sarah, you can get a discount at the moment. So I hope that was a fairly useful session for you. And I'm happy to take some questions. So I'm going to stop sharing and go back to Sarah. Sarah?
Sorry, I'm still here. I was just.
Oh, I didn't. I was audible all the way through.
Yeah, so I lost my connection a couple of times, so hopefully it wouldn't have affected the recording.
Okay.
Can you see the Q&A box, Steve?
I can.
Take my glasses off.
Shall I click it?
Yeah.
Okay.
Okay. Would you like to have a look through?
Okay. Some of these questions, okay, are about seeing and hearing. Okay. Okay. So, can they hear me?
1 second. Where's the chat box? Yes.
Okay. One person, Joe, asked, could it be working memory? I mentioned that. No, I don't have. Someone asked about, Catherine asked about maths difficulties in low birth weight premature children. And the answer is no, I don't know. But, you know, any problems, well, I've had, no, I don't go into my personal things, but two difficult issues around children of mine. It does tend to up the risk. Color to teach numbers. This is Joe again. The Numicon materials are quite colourful. Cuisenaire rods, which are yonks ages old, are quite colourful. Got to be a little bit careful that, you know, you say, Joe, red is always one, but you might meet some things later on where red is not one. But colour, use carefully. I like that, you know. Okay. Penny was asking about helping her son to revise for GCSE next year. I think pick out some key questions. Ask the teacher what are the most frequent types of questions to come up. That'd be one thing to do. Focus in on those. Try and get your son, listen to how he analyzes a question. Ask him, how are you tackling this question? And see if that can help. Let him learn which are his strong points, because in exams, that's kind of helpful for focusing in on those. So I'm a bit sort of succinct in my answers. So Joe again, back on working memory. Should we improve working memory or mathematical facts first? Go for mathematical facts first, Joe. Improving working memory is more controversial as to whether or not it works, and if it does it transfer for the maths? So if I'm going to use time, I'll use it on stuff that I know is going to be beneficial, so go for the mathematical facts. But interventions, yeah, look at lots of different things. Okay, Carla, New Zealand. Hi, New Zealand. My gosh, you must be an insomniac. Uses a tens frame, 5 in a vertical line. Yeah, I like my 5 pattern, but not exclusively. Kind of like the colors, because I want, for a lot of the times, I want people to recognize the 5. So that's why I use that. But it's harder looking at a vertical line and knowing it's 5, particularly when you know, you have 9 in a vertical line. Yeah, Rachel, at what age do you expect students to memorize their times tables and just provide a calculator instead? It's not always allowed, and it's very unlikely that accommodation will be given for exams. That's my guess. So teach her how to work them out. Yeah, I've got time. What I suggest for some kids in school exams, and indeed any exams, if they know the methods that I've shown you an introduction to, you get them to be given some squared paper. They can quickly construct an outline on table. So 0 times 10, 0 times 10. And then fill in just 1, 2, 5, and 10. Nothing else. They can do that quite quickly. And if they've got those filled in appropriately on the times tables, then say, for example, they want to do 7 6s, they can go down the 5 6s column and the 2 6s column and get 30 and 12 and get the 42. So that's quite a handy tip for exams when you can't take calculator in. Singapore maths, yeah, I've done some, well, I've done a lot of lecturing in Singapore, done some consulting for the government. It's not necessarily what is officially done in Singapore, but it's based on the work that's done in Singapore. I kind of like the fact that it uses the visual images and the digits. So it's a ready scheme for teachers who are not confident enough to develop their own work. Early years maths, absolute must. Associating the symbol with the quantities, that's early year maths. Learning early links between adding on by counting, by relating it to counting. Early work on simple place value. Okay, thank you for the compliment, Sleepy Sheep and Mandy McCabe. And indeed, oh, anonymous attendee. Oh yeah, keep it quiet. Yeah, any visual presentation is going to help a lot of kids. So yeah, angles, percentages. If in the video tutorials, a lot of stuff on visual presentation, percentages, angles. Still on the drawing board. I haven't done that yet. Although there's a bit about circumference and pi and stuff. Apparatus for whole school. What should we be using to support all learners? If I went in a school as an inspector, and having been inspected so many times, it's unlikely I'll ever become an inspector. If I didn't see base 10 blocks in your school, I'd be kind of worried. Really good idea I got from a teacher talking once. She gets those toolboxes you can get in DIY shops, which look kind of cool and grown up, and she puts apparatus in there. And she puts things like calculators and compasses. So kids go and get a toolbox for all sorts of reasons. Sometimes people think apparatus is kind of babyish, but you know, it's not. I used to teach physics. If you didn't teach physics with apparatus, you'd be in deep trouble. Particular screener, there's not particular ones. There's a lot around. You'll have to find one that works for you. I have a book on assessing maths learning difficulties. All the tests in it are free to photocopy, and in there's a Dyscalculia checklist. But if you ask Sarah really, really nicely, I'll give a copy of the checklist to Sarah and she'll send it to you. I have to emphasize there's no score. It's got like 38 common things that kids struggle with, but you know, there isn't a score. Like if you get 30, you're dyscalculic. If you get 29, you're not. It helps you build the IEP as well, and it's free. So that's kind of good. Yeah, people asking for copies, Sarah. That's down to you.
Yeah, no problem.
What are my views on Numicon for helping with dyscalculia, Kirsten? Guinea month. Well, as it happens, I'm doing a little bit of work for Numicon. In fact, I was doing some stuff today with them, and Numicon are going to present some stuff around about June, July time, targeted at kids who are falling behind. So there's about 12 weeks of intervention for kids who are struggling, based around Numicon and base 10 materials. And I've done a fair bit of that stuff. So my views are that obviously I kind of like that stuff. Question from Michael McCarth. Child who can't read large numbers at all but can work with quantities. What can we do? Hard to know without working with an individual child, but keeping them together all the time. Maybe having some plastic numbers which they put with the quantities, you know, so that it becomes something they're physically doing, and then they write. So lots of multisensory input. Very tricky to recommend schools, so I'm going to avoid that question. Always a tricky one. Is it, Suzanne Crosby, is it more prominent in girls? Hard to find concrete evidence. It would see, some researchers said it is. And if it is, it would be the only learning difficulty that's more prominent in girls. Males get a tough time. It doesn't mean to say girls don't get stuff. It just means that usually the male population is dominant. But the research is not clear. But in some of the early papers, people suggested that might be a case.
Was it male researcher? I'm not saying anything. Sorry.
I'm not even going to.
Don't get me started.
Is there a way to increase working memory? Tracy Packham Alloway is the big Tracy Packham Alloway is the big name in working memory. Not everyone agrees that you can do it. She thinks you can. Maths. Bev has a daughter with dyslexia, dyscalculia, and dyspraxia. Dyslexia and dyspraxia often is not a good combination from the maths point of view. Have a look at some of my maths tutorials. They're not expensive. Get the school to buy them because there's no license fee. And then your daughter can have a look. It's not the only thing I do. There's quite a lot of nice games around from people like Dynamo Maths and Number Shark. So you need a range of things because you never can be sure. Help slow processing speed. Huerta Anna was asking, how can you help slow processing? Get kids more automatic, which means probably with a smaller number of things, and that's one of the ways. Lots of practice, lots of familiarity. Focus on the stuff you can do. It's about being efficient in your approach to work, particularly to exams. Ellen Garrett said, "How old do you think children need to be diagnosed with dyscalculia?" I think you can probably have suspicions very early on. In my own book on diagnosis, I kind of reckon around 7. But I would do informal tests with younger kids around that around classification, seriation, counting forwards and backwards. And I would try to get kids who are at risk and get the intervention in for them. That would be my approach. Okay. How high is the comorbidity? This is Nicola Hobbs between dyslexia and dyscalculia. Quite a bit of research on that. When I worked in my school with dyslexics, and in the early days, they came to me primarily for dyslexia. We didn't really know much about ADHD or actual developmental coordination disorder. We certainly didn't call it developmental coordination disorder. We didn't know much about Asperger or autism. But I was stunned by how many of my dyslexic students had some problems with maths. In fact, nearly all of them had some problem in maths. What was different was the prognosis, how the kids came out. So we get kids with A stars and some that got Ds. Very, very rarely did we not get a D and then later a C. So it depends on the severity, I suppose, of the dyscalculia. But things like working memory, short-term memory, symbols will affect both of the, reading and maths. This question is a very interesting one for me, and I'd love to do some research. Chloe Barnett. I teach post-16 kids with SEND who've often not engaged in maths for years at school. I just feel so sorry for those kids. And it's not a small population. They switched off at 7 or, whenever. I do recommend going back to basics, yeah. But you've got to do it in a way that they'll buy into, and you know that as much as I do. And the strategies that I use, and you see them in my book and stuff, that's what I'd look at. You've got to make it successful for them. You're only going to get motivation back if they get some successes, and they mustn't be patronizing successes. So have a look at some of the stuff I've got online and some of the stuff I've got in print. So there you go. Yeah, anonymous attendee. You're back. Still anonymous. The Dyscalculia checklist might help you to go back. It pinpoints some of the problems. Peter McClive asks, he's not a relative, honestly. Thanks for your talk. With times tables, could you show how to use the facts from 1 to 10 using just the 2 and 5 times tables? Yes, it's in my books. I have a series of books wrote ages ago called What to Do When You Can't, published by Egon. There, they do it. My online webinars at Maths Explained. That's online tutorials. They show you that as well. So, and then something like $2.50 might cost you $5 to find out how to do it. You can't buy a book on times tables in Marks and Spencer's for £5. I don't know about links between epilepsy and dyscalculia. I don't know. It's not been a line of research I've followed. Gail Eisen talks about 4 children with a variety of difficulties, but all struggle with maths in year 3. Stop taking part in the daily lessons. Yeah, someone asked me that question. In fact, a very good friend of mine asked me just that same question. What do you do? I think it's kind of tricky because you don't want them to get further behind. Maybe they could stop taking part in 1 or 2 lessons, but it'd be much better if they could have a couple of additional lessons. But in a sense, and again, you don't know about the personalities involved, but it's kind of pointless being a lesson where you're not gaining anything. And that might be one of the ways you get evidence to take them out. You know, how much do they learn in the last 3 lessons? And if it's nothing, that's a pretty strong argument. You know, get the teacher to do a pre-test and a post-test on the topic he's teaching. And if the kids have not gone forwards, or even worse, gone backwards, that's strong evidence for taking them out of the class. So try that. Is it necessary for kids to learn times tables? Sharon Collins. I was at a launch of a new dyslexia group on Monday, Tuesday, can't remember. And it was a very small, select launch, which is why I was there, of course. That's a joke. And the person they had to do the launch was called Richard Branson. And I'd heard of him. And there was an article about him and this launch in the Sunday paper. And he was there at the launch. Lovely chap. And he said in this little article in the Sunday Times, I never learnt my times tables. It hasn't held him back as far as I can tell. So, no, in terms of Richard Branson as a one-off case study, it hasn't held him back. But in schools, it can become an issue because schools make it an issue. And it's what I said about discrimination. When you say my 9-year-old will remember them for a week and then forget them, sometimes kids only remember them for a night and then forget them. So I like the methods I've done because we use them in my school. They were successful, and it tells you how to work them out. It gives you security. Because why should 7/8 be 56? If you use methods that tell you how to work it out, you know it's 56. And the more you get rid of the wrong practice, the more the right practice will work. Video tutorials, grade 4, yeah, Colleen. Yeah, they're designed really for any age. Pick the ones that are the topics that are right. They're not age specific, so older people can use them as well.
I will send out tomorrow, everybody, some links to Steve's website, and as you said earlier, I have arranged for you to have a discount on the programme. So if you want to check out, just look out for your email tomorrow.
Okay. Leah Dowds, is it okay to use sing-song to assist with times table learning? Pick a good tune, because that's what they'll remember. Those are more tricky. It'll only work for some kids, you know. It's still rote learning. So, yeah, go back. Work out how to work them out. Get the 2s and the 5s. That's the big deal. Functional, this is Atul Rana. Would you recommend functional skills instead of GCSE? It depends. Functional skills are very wordy, very lengthy, and it depends on the profile of the kid. It's horses for courses, so it's nice to have a choice. I'm old enough to remember CSE. Probably most of you won't remember those. But it was kind of good when we had CSE and GCE because you could kind of pick the exam that was better for some kids than the other. Can't do that anymore. Okay, going down. I'm missing 1 or 2 because of times. Oh, Emma W., who's got a son who loves fractions. Treasure him, Emma. He's a rarity. And it's lovely what he does. And the working memory, I'm so sorry. You know, it's such a thing. and again, times tables. You know, it's such a big problem. Have a look at the video tutorials again, because of the visual images to support memory. And that's the deal. Some of these questions would take me a day to answer. Rebecca Hainsworth, how do we help our kids choose which methods to apply to problems? That comes with confidence. When you're not confident, you want one method and you want it to work for everything. Being able to look at a question and think, oh, how can I do this? Can I do this? Can I do that? That comes with confidence and lots of input. Do I use a lot of movement in my teaching? Only me. I can't stand still. So I'm moving around all the time. Sorry, not a good answer. Hi from Australia. I shall be in Tasmania in September. Repetitive games. I think anything that helps. Repetitive games are okay because it's a little bit of practice. But go for the concept. That's the best thing, and then have a bit of practice. Best strategies to teach fractions, percentages, and ratios and decimals. New ideas in my video tutorials. Again, cheap and cheerful. So that's that. Sharon. Primary maths teaching is so different to the way I was taught back in the 70s. And Sharon, have a look at, I'm trying to remember his name now. Oh, I've forgotten his name. It'll come to me. The way you learn things will be dominant in your brain, like I've hinted at. And that's a real problem. So it's very hard for you to adapt to the way your son's doing one. And it's Tom Lehrer, L-E-H-R-E-R. Tom Lehrer. Google Tom Lehrer new math and just watch the video. It is so funny and it'll make you feel better. And that's something. Specifically using methods for word problems. Now, I will go back to Singapore, and what is government produced in Singapore is the Singapore model method for word problems. That's not Singapore maths or other things that are commercial. Google Singapore model method for word problems, and that'll give, it might well be in Singapore maths, but that actually is official Singapore stuff. And I can tell you, you see the word problems kids do in Singapore. Oh, I was doing those at degree level. Oh, maybe not quite that bad, but they are really good. But of course, not all kids. Okay. Average age dyscalculia can be diagnosed. I've kind of talked a bit about that. We must be running out of time here. Maybe we could bring you to New Zealand. Carla, thank you very much. Too late. I'm in New Zealand in October, but I've got no time to talk. I'm just going to look at your beautiful country. I haven't been for 25 years, so I should be whisking around South Island in September, but unfortunately no time to stop. Maybe another time. Catherine Carlisle, my child hasn't had much success with Numicon, but it's something the council likes to use. Well, I've talked about Numicon. What you have to remember is that nothing works for everyone, and it is the problem when you follow one scheme. It's why I like the idea of the toolbox for the kids, for the teacher, so you can, if one thing doesn't work, you can move to another. Sometimes you have to go for kind of a one apparatus and then find other stuff for the kids that can't do it. So, like I say, lots of flexibility for teaching, for learning.
Do you want to just do another couple?
Yeah.
Is that okay?
Oh, Maggie MacDonald. Why do we always start teaching kids addition when subtraction is easier for them to understand? I don't actually have much. I don't think that's often the case, Maggie, with a lot. It's addition they can do. Subtraction involves reversal, counting back. I haven't found that it is easy to understand. I kind of like sometimes teaching both of those things together if I can do it without confusing, because they're complementary, and that's good. And I don't talk about other people's materials. There's a lot of questions that are obviously repeated. Okay, as Rina Assad, we'll do one more after this. I'm trying to find alternative methods in place of conventional methods like long division. Would this be confusing, as they would have to face conventional methods in school? Really good question, because again, in my video tutorials, I show you an alternative method of division, but it actually complements the traditional method. So what I've tried to do in a lot of the stuff is teach maths as it is to the kids as they are. So I modify the methods, keep the principles the same to make them accessible to kids. It's kind of sense for me. So, okay. Okay. Janine Sandel, last one. My son's maths is full of small errors, plus instead of minus, etc. Seems to understand the concepts, but can't seem to pass the test. Any advice? Janine, not specific, except slow him down, give him a highlighter, get him to focus, take the pressure off. Research on errors. The most common errors are small errors, careless errors. Those are the most common errors. No matter how good you are at maths, those are common errors that people make. So a bit of highlighting, a bit of slowing down. One of my brightest kids, I'll end on an anecdote. I gave him a standardized test, basic arithmetic. He finished first, which he wanted to do because he was very competitive. Unfortunately, he added in every question. Addition stopped after question 5. He didn't recognize it had gone to subtraction, to multiply, to divide. He got every question right in terms of adding, but just not in terms of the test. So slowing down and highlighting and trying, to identify the type of small error. Are they also arithmetical errors? So thank all of the people I can't see for listening, and I can't see any of you, so thank you everyone for listening. Thank you, Sarah, for organising it. Brilliant job, and good night.
Good night. Thanks very much, Steve.
You're welcome.
Thank you very much, everybody, for coming. I lost my connection twice during the webinar, so I'm hoping that you were still there and it was just me that was booted out. I will, as soon as we're finished, I will put this all together onto a recording and I will email you tomorrow. I'll also go through the chat. Quite a few people have asked for the recording and for the worksheets, sorry, the checklist that Steve mentioned. I will make sure that you have all of the information that we've talked about today in an email for you tomorrow. I'm really pleased that you did that, Steve, because I know dyscalculia, it's just one of those things no one seems to know a lot about. There really needs to be more awareness out there. And I know the times table, obviously, with dyslexia, how they interact. There's hope for me yet, maybe, learning my times table.
Sarah, can you still hear me?
Yes, I can. Yeah.
One of the Q&As from Ellen Gareth, Lois, who is 10-year-old, is watching, and she's very excited that she can now do 7 times tables. Thank you very much. Well done.
Well done.
Well done.
Brilliant. Okay, everybody. I will let you get on. I'm sure you're all sat there nice and comfy in your pajamas. I'm going to join you. Have a really, really good evening. Please go along over to the Operation Diversity Facebook page, and if you enjoyed the webinar, please leave us a comment on there. Check out as well if we have any parents here that are based in the UK. On the 1st of May, we launched something really exciting called the Operation Diversity Academy, which is a huge support network with all of these webinars and all sorts of other things. But if you search Operation Diversity Academy and have a look at that as well, we'll be happy to welcome you into our membership community as well. Okay, good night, everybody.